So this is the schematic view of the data. We may also want to add in geographical data for our substations and our lines. We select our geographical editor. Once again, we tell it we want the example network. By default, we will use the WGS84 coordinate system, which is latitude and longitude. But we support a number of different coordinate systems. So this shows us just a blank map. It has no idea where anything is, so it just zooms out to the maximum. So if we zoom in a little bit, we can view here Western Europe. Scroll across and we're getting into more of the entire ENSOE footprint. So it's grouped our substations by primary substations, which is those substations with transformers, and the other ones. If we click on hotel here, double click in the map, and it'll add it to the map at that location. Clicking in kilo, we can similarly add it. The lines here automatically determined, so it knows the connections between the substations. If we right click on a substation, we can also see that other substations are connected. So clicking in Bravo allows us to place it. Clicking in India, we can place it. And you can see it's connected to the other substations, and the icon here shows that it is a generating unit. If we click on India, we can see it does indeed have a thermal generating unit. At this point, we can also, if you move the icons too close to each other, you start getting clustering. So we want to turn that off for just now. Juliet is also connected to here. So now we also see that on the low voltage side, what networks are there. So perhaps we're moving these in the wrong direction. So you can see when we click here, these are in grey, which indicates they're already placed. So if we click on them, it navigates to them. Similarly here. So we still have Golf to place, and it's connected to Foxtrot as well. Our last stations here were Alpha and Charlie. So this has now placed all of our stations in the map. Of course, we also want to add in line routing. So if we click on a line, double clicking in a point will add in a breakpoint, so we can start to add line routing information. So we can see that this location has 4 points. Once again, over here we can save. The final thing we can do with this network, because it is a test data, is we can actually run a power flow on it. So if we select our example network, it builds up our internal power flow model. We can see here the basic of the model showing the buses, the branches, and the transformers. We can execute the power flow, it converges successfully, we can see the total generation and load, the losses, and we can see the P, Q, and P from across all of the different branches here. We tell it we want to create state variables, save them into the resource, and we want to remove any existing state variables, so we want to replace the ones that are already there. When we click finish, it's now replaced all of our power flow information. If we reload our map, we can actually view the power flows on the map, and we can see here where the majority of the power flow is going. The different arrows indicate real or reactive power flow. So this is all being driven from the single data source here, which is CIM, and we're using our database repository to keep track of all the changes we make. So when we save here, we can call this one power flow results added. The initial SV variables are there indicate the starting condition rather than the results of a power flow. So what we can also do is open up any historical version at any point. So if we want to go back before we added in the overview diagram and just had our set containment and names, we can view a read-only version of the data here. As you can see, there's no diagram data. Comparing it, if we load them side by side by dragging it across, you can see there's a number of different classes that are not in the previous version because we don't have any of the location data or the diagram data. The last thing we can do is validate the data to check if it's conforming to all of the rules. So if we take the profile group for ENTSO-E, which is equipment, topology, state, diagram and geographical within it, we tell it we want to run the validation. You can see here it's actually flagged an error. Our substations are failing because they're looking for a sub-geographical region to be set. So what we can do here is actually tell it by clicking on the plus icon there what we want to add in. In this case, we want to add a sub-geographical region from CIM15, and we just want a single instance. So our sub-geographical region fails because it needs itself to be part of a region and needs to have a name. So we'll call this France. If we click open the empty links, we can see here that it's looking for our region. We can actually add the object and add the association at the same time by adding the reference. We want to create a geographical region. It's automatically determined what subclasses are available, in this case only the one. So we add that in, and we can give our geographical region a name, and we'll just call it Europe. So now we have our sub-geographical region and we have a geographical region, so we can view the model in its hierarchy. But of course it stops here because we don't have our substations added. If we also select our substations, we can select our substations and our sub-geographical region together. We can drag and drop the substations in here to add the association. So now all our validation is complete. We can tell it to open a validation report, which opens a separate window showing that there's no constraints failed, so we have nothing we really want to export here. We can now once again save this. So we now have a valid ENTSO-E CIM model for our 14 bus with diagram data and geographical data. Everything is stored within the local repository, and we can pull back to an earlier version to view it. If we want to, we can export the data out as a single RDF file. Alternatively, we want to do a profile export. We say we want example network, we want to do ENTSO-E profile, 14. We can put it into a zip file. And tell it where exactly we want to save this. In this case, we'll put it under example networks. Click finish. This now takes a copy of the data from the repository and writes it out to a zip file containing all of the multiple files. Double clicking in that allows us to see it's loading up the IEEE 14 ENTSO-E zip file. We will call this our IEEE 14 file. This will pull together all of the files that are within that zip file, integrate them together and load them up within the browser. So we can see here, when we look at the loaded workspace, we have our IEEE 14 file that contains these multiple files, all integrated together to produce the same network, but as profiled RDF XML in a zip file.